Right, I want us to look at this very interesting topic called problem solving, where we check your problem solving skills, usually without using a calculator. This is what you're given here. This times that minus this times that. Looking at this will tell me something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. So there's something common in all these values. In other words, this is exactly the same as this one up to here. It's exactly the same as this one up to here. It's the same as this one up to there. They are exactly the same. Now, let's represent them with something which is similar. So, which is the same. We let 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 be equals to x. Let's call it x. If this is x, so this is 93, so it will be 90 plus 3, 90 plus 3, and so on and so forth. So how can I write this when we know that this value here is equal to x? So it will give us, this will then be x plus 3 to give us 93. So what is that one going to be? Remember, we're multiplying this with this one. So if this is x, so we plus 4. So this next one will be x plus 4. That's what we have that side. What do we have on the other side? Remember, up to 90, we said it is x plus this is 95. So this is x plus 5. So this is minus into x plus 5 times again. What will I have that side? This is 90 and 2. So it's 90 x plus 2 in this particular case. So this is x plus 2. This is what we have. Remember, this negative is in everything there. Let's work it out. This then will be, let's multiply this quickly. What is x times x? It is x squared. Look at this, 2, 4, and 3. It is 7. So this will be plus 7x. Then when you multiply those two, they will give us 12. 4, 8, 12. That's what we have there, minus. Remember that there's still this bracket here. This is x times x. It is x squared. Look at these two numbers. They give us 7. So it is plus 7x. You multiply those two, 5 times 2, it will give us 10. That's what we have so far. The next thing that we need to do is to break those brackets. Let's break them together. This then will be, this is x squared plus 7x plus 12. Let's break that bracket. We wrote this as it is. Now we're breaking that bracket. Negative times positive, it will give us negative x squared. Negative and positive, it is negative 7x. Negative and positive, it is negative 10. Then we look for like terms. X squared minus x squared, it goes nothing. 7x minus 7x, it is 0. What is 12 minus 2? 12 minus 2, it is 2. So that is the value of this expression. It is just equals to 2. This is what we call problem solving, where you look at things, you try and find the best possible way to solve that particular problem. In this particular case, we saw that this is exactly the same thing, exactly the same thing, exactly the same thing. So the same thing plus 5, the same thing plus 4, the same thing plus 3, and we came up with these mathematical expressions, and we were able to solve it up to the value 2 there. At times, you can find it in any form. You can find it including exponents and sides. And that particular form there, that kind of problem solving. But when we use our eyes, we look for something that is exactly the same, like we did in this particular one. So when I come to this side, I'll be using the same experience that I got in the previous problem. So what is that I see here? This is 10 to the power 2009, 10 to the power 2011, 10 to the power 2007. So there's the one that is appearing in all of them. In this particular case, it is 10 to the power 2007. So what is this saying to me? Here I've got square root of, this is equals to the square root of, let me say 10 to the power 2007. Square root of 10 to the power 2007 plus to get 9. So it is plus 2. That's what we have there. Because 7 plus 2 will give me that 9, exponential laws. If you multiply powers with the same base, you add the exponents. In other words, this is still 10 to the power 2. So let's look at the bottom one. If I want to have something that is the same as I had there in 1, 2, 3, 4, 5, 6, 7, 8, 9, that's what I see. I see the 2 to the power 7 here, which is also available there, which is also available here. When you move on to this next one, look at this one. This is 5 to the power 2007, 2, 2010. This is 5 to the power 2009. This is 2008. Which one appears in every one? It is 2 to the power 7, 2007. So that's the one that I'll be using there. So in this particular case, I see the 2 to the power 7, which is the smallest in all of them. So I use that one. Right, this is divided by what here? This is divided by the square root of 10 to the power 2. What is 7, 8, 9, 10, 11? So it's 2007 plus 4. Does this give me 11, 7, 8, 9, 10, 11? Yes, it does. Minus 10 to the power 2007. What I wanted to keep. All that I wanted to do is to make sure that each and every one of them has got something which is common to everyone, creating a common factor in that particular case. So what do I have here? If you look at this one, I take this one out. In other words, this is the same as square root of 10 to the power 2007 times square root of 10 to the power 2. What is that going to give us? In other words, we've got 10 to the power, let me write it, times square root of 10 to the power 2. That's what we have there. This is divided by. Right. Let's look at our denominator. That's my critical point. That's what I wanted to get. So I've got there the square root of 10 to the power 2007 times square root of 10 to the power 4. That's what I have there. This is minus square root of 10 to the power 2007. Right, that's the position that I wanted to see. Right, once I have it in that form, I use my eyes. Here there's this, and let's look at the denominator. There are two terms with denominator, but there's one term there because there's no plus or minus there. It's just a multiplication sign, so it's one term. But here on my denominator, I've got two terms, and there's a common factor between this term and this term. What is our common factor in that one? What is it that we see in this particular side and also have it on that other side? It is this one. This is the same as that one. We call that a common factor, factorization. The first part becomes important there. Our eyes are very important. Let's look at what we have now. On the numerator, I've got 10 to the power 2007 times. What is 10 squared? It is 100. What is square root of 100? It is 10. So it is times 10. This is over. Remember this is still under a square root sign. Let's take a common factor between those two. If I take a common factor here of square root of 10 to the power 2007, what will I be left with? I'll be left with 10 to the power 4. What is the square root of 10 to the power 4? In other words, there's 2 here. You divide by 2 there. It will be 2. It will be 100. 10 squared, it will be 100. So this is the same. This is the same as 100. Minus. What is it that I have there? If I take it out as a common factor, remember this is what let me just not put so many brackets so that it will make sense. This is times. Remember that I've taken this one in the denominator. If I take this one, I'll be left with this one. In this case, which is 100, the bracket is there. Then there's this minus. If I take this one out, I'll be left with 1. That's what I have. Let's look at it once more to check if there are any mistakes. One more. We've got this one and that one, right? This one is here. This one, there's 2 here. You divide by 2 there to kill the square root sign, this sign. 2 over 2, it will 1, which is 10. Correct. We've got 10 there. In the denominator, what do we have? We've got this one, which you take out as a common factor. We're left with this one. There's 2 here. If you divide that by 2, it will be 4 over 2, which is 10 squared. 10 squared is 100. Then minus. If you take this one out, we're left with 1. Right. Let's write the solution now. From here, it becomes easy. You can see things that can cancel each other. This one goes with this one. It is gone. It is exactly the same thing. What is it that we're left with? The final answer will be 10 over, what is 100 minus 1? It is 99. This is what we call problem solving. The value of the exact value there, it's 10 over 99. Let's look at the last one now. Let's look at the last one. It is exactly the same idea, the same thinking behind this, the same thinking behind the problem solving. I use my eyes. This is 5 to the power, 5 to the power, 5 to the power, 5 to the power. There's something common there, 5. Let's look at the exponents. 2007, 2010, 2008, 2009. That's what we have there. I look for the smallest of all. In this case, it is this one, 2007. So that's what I will keep in all of them, because it will appear everywhere. Let's do this thing. So this then becomes, this one will be 5 to the power 2007 plus, how can I get 2007 here? Remember, it is 10. It's 7 plus 3, that will give me 10. So I want to keep 7. So this is the 5 to the power 2007 plus 3, because this together will give me that. But I want it to have 7, 2007. Let's look at my denominator. It's the same thing. I want to keep 2007. It's it's 5. The base is 5 to the power 2007 plus 1. This will give me 2008 plus 5 to the power 2007 plus 2. It will give me 9, 2009. Right, that's what I have. So I can see it clearly now. They all have the 2007. So half the battle is 1. Now let me go for a common factor. Remember that if I've got x to the power 2 plus 3, this is the same as x to the power 5. Right. Or it is the same as x to the power 5 times x to the power 3. So must be able to see that those two are the same. What am I saying here? I'm saying if I'm coming from here, I'm going to deal with that one. There is a common factor here. But I know that this is the same as 5 to the power 3. 5 to the power 3. I must not forget that. So if I take this one out as a common factor, which is 5 to the power 2007, in this side here, I'll be left with 1. Because this times this, I must get that as it is. If I take out 5 to the power 7 here, what am I left with? I follow the sign first, which is plus. If I take this one out, I'll be left with 5 to the power 3. 5 to the power 3. That's what I have that side. Let's do the same thing on our denominator. Remember where this 5 to the power 3 comes from? From this information. This is the same as x to the power 3. So this is the same as 5 to the power 3. So it is left here, the 5 to the power 3, because I'm taking that one out as a common factor. I do the same thing on my denominator. If I take out 5 to the power 2007 as a common factor, I'll be left with 5 to the power 1. Not 1, but 5 to the power 1. Because when you multiply powers with the same base, you add the exponent. So there was 5 here. Plus, you follow this sign on my denominator. If I take out 5 to the power 2007, I'll be left with 5 to the power 2. That's what I have so far. Right. Let's go further. This goes, that goes. What am I left with? What is 5 to the power 3? 5 times 5 times 5 gives us 125. 125 plus 1, it will give us 126 over. What is 5 squared? It is 25. 25 plus 5, it is 30. Right, that's our solution. If we go up to there, I'll be happy with it. That's what we call problem solving. Thank you.